Okay, so we're throwing a ball. In fact, that ball must be getting thrown at a speed of 160 feet per second, but we don't need to know that. We're given a function that relates the distance above the ground, s, as a function of t, time, written as t, where t is how many seconds after the launch. We're asked two questions. When does the ball return to the ground? And when was it 400 feet above the ground? Now, it's never going to go below the ground. It's going to hit and be done. But because gravity is going to slow it down, it's going to reach a maximum height and then come back down. In between, there are two times launch of t equals 0 and what we're looking for in part A, that it will be at a height of 0, a height or a distance. Everywhere in between, until we reach that maximum height, there will also still be two values of t, where it's at the same height on the way up and coming back down. It's never going to get above a certain maximum height, but we don't know what that maximum height is. So, for the first part, we're looking to solve when is s equal to 0, because that's what ground level is represented by. And the most straightforward way to solve that quadratic equation would be to factor out the greatest common factor and make it negative because the lead coefficient is negative. So I'm going to factor out a negative 16t, and that will leave me with t minus 10 as the other factor. Setting each factor equal to 0, divide both sides by negative 16 on this. Well, that first one of t equals 0 seconds, we already knew that. We're looking for when it returns to the ground. So t minus 10 equals 0. T is equal to 5 seconds. That is when it is returned to the ground. So what about the second part, where we want to know at what times or what time, if it happens to be the maximum height, to get to that height of 400? So let me leave that there a moment. For part B, instead of 0, we've got it at 400, and we can divide all of these by negative 16 as well. (400) divided by negative 16 should be negative 25. I'm going to quickly check that. It is. I could continue by a variety of approaches, get it in standard form and do completing the square, get it in standard form and factor, or use the quadratic formula. I can't use the square root property because t is in two places, but maybe it's nicely set up for completing the square. However, if I add the 25 to both sides, I'm seeing something that is already a binomial squared. This can be factored into the quantity t minus 5. All of that squared is equal to 0. So when you take the square root of both sides, plus or minus 0, square root of 0 is 0, plus or minus that, you still have 0. So you're just getting a single solution of t equals 5 seconds for it to be at a height of 400. So why aren't we getting two different values, as I was saying we could get for some different heights? Well, it's right there at its maximum height. And anything higher than that, if we put in 400, we'd be getting stuff that we couldn't solve, or we'd be talking about complex numbers for time. That doesn't make sense. The way I know that it's at the maximum height is by a formula for finding out the first coordinate of the maximum height of a parabola. That looks like something related to our quadratic formula. So if we just take that part, b was 160, so we've got negative b, negative 160, over 2 times negative 16, negative 160 over negative 32 is equal to 5. It's telling me this point, that is the maximum, is 5 comma 400. At 5 seconds, the ball is at a maximum height of 400 feet.